The overall goal of this protocol is to provide a procedure for preparing new supramolecular ionic liquid crystals based on halogen bonding, starting from non-mesomorphic building blocks.
The halogen bond has become a tool for controlling aggregation and surfacing phenomena, and it can play a very important role in determining physical and chemical properties of biomaterials. The halogen bond is strong enough to overcome the low affinity existing between perfluorocarbon and hydrocarbon compounds and can be exploited to introduce any fluorinated modules into any supramolecular material.
Generally, people new to this method are suspicious because halogens are electron-rich species. However, in covalently bound halogen atoms, a region of positive electrostatic potential appears along the extension of the covalent bond.
The ability of an ion to be involved in halogen bonding and the high directionality of the interaction gave us the idea of applying this method to anionic liquid crystal design.
To prepare the halogen-bonded complexes from solution, first dissolve 50 milligrams of the imidazolium salt in 0.5 milliliters of acetonitrile. Next, dissolve 229 milligrams of perfluorooctyl iodide in 0.5 milliliters of acetonitrile. Mix the two solutions in a vial. Then, place the vial in a jar filled with paraffin oil and let the solvent diffuse slowly in the oil at room temperature.
It remains challenging to anticipate the composition.